This is 6.3 day 2, and we're going to keep using all of our ideas of whether or not polygons are similar to solve a few more problems. So it says list all the pairs of congruent corresponding angles. And so we're going to go with angle A goes with angle D. Reminding you that you can also use how the letters are laid out in the similarity statement. So B, the middle letter, has to go with E, which is the middle letter. And then C, which is the last letter in the statement, has to go with F. Sorry. Next one says, can you write a statement of proportionality? We sure can. We're just going to match up all the sides. So I'm going to start with AB, going with DE. And then I'm going to do BC, has to go with EF. And then I'm going to do AC, has to go with DF. I'm also going to do their numbers. So that's because it's going to ask me to check the ratios of corresponding sides. We'll do that down here. Okay, so AB is 25, 35, 30 goes with 42, and 20 goes with 28. Now we have to check and see if they're all the same. So I'm going to do 25 divided by 35, 30 divided by 42, and 20 divided by 28. Looks like they're all the same, so these two shapes are similar. What could I write here? Oh, sorry, let's reduce this. So we'll just grab this one and I'll divide by 4. So that will be 5/7. So that's my scale factor, taking any one of those fractions and then reducing. The theorem we're going to talk about today says if the two polygons are similar, so once we've decided that they are indeed similar, then the ratio of their perimeters is equal to the ratio of the corresponding lengths. Lots of words. Just means that once you figure out the scale factor, that also works for perimeter as well. So if this shape was twice as big, then its perimeter will also be twice as big. It's kind of a duh thing. You're just adding up the sides. So once you know your scale factor, you can use that to help you find the perimeters as well. Okay, the town is building a new swimming pool. An Olympic pool is rectangular, just like the new town one, with a width of 25 and a length of 50. The city's pool, the new pool, is going to be similar in shape, so still a rectangle, but only 40 meters long. We don't know how wide it's going to be. Find the width of the new pool. So I'm just going to match them up. Width with width and length with length. This is a cross multiply and divide problem for us. So 25 times 40 and then divided by 50. So it looks like the width of our new pool is going to be 20. Find the scale factor of the new pool to the Olympic. So this is small to big. New pool has a measurement of 40. Olympic pool's match is 50. So the scale factor of those two, 40 to 50, and then we want to reduce, so I'm going to divide them each by 10. So I'm going to end up with 4 to 5. Find the perimeter of the Olympic pool to the new pool. I can just use my scale factors to figure those out, or I can figure out what all of the sides will be and then add them up for perimeter. So on a rectangle, kind of nice. I know that those are 50 and 25. We know this is 20 now, so 40 and 20. So my perimeter here will be 150. My perimeter here will be 80, 120. Find the perimeter. I bet I meant the ratio of the perimeters, but that's okay. We will divide them each by 10, so take that off. And then I can divide them each by 3 as well. Oops, not 2 equal signs. Then I can get 5/4. So that perimeter, that scale factor that we were using, is relatable to also the perimeters. Last one has, if these two shapes are indeed similar, find the length of the altitude PS. So this right here is called the altitude of a triangle. I'm going to throw an X on there because that's what we're looking for. So it looks like X goes with 20. And it looks like this whole side, which is 12, goes with this whole side, which is 16. So a little cross multiply and divide. and I've got x is 15. So keep using all those properties of similar shapes, how you write out the corresponding angles, your statement of proportionality, finding your scale factor, so that you can figure out various measures on similar shapes.